Welcome everybody. This lecture is about histogram. A histogram is a specific type of a vertical bar graph. Before I start talking about particular example, let me just show you what that might look like. So this is a type of a vertical bar graph that is called histogram. Okay, how is this done and what it represents? Here I have an example of 30 purchases of a random customer in a gift shop, and those purchases are rounded to the nearest dollar. The first thing you need to do with that is to organize the data in some sorted format, and I'm organizing the data in format that is ascending. So the first thing I have is the smallest thing, and the last thing I have is the largest thing. This could be done manually. You could just go stroll through the data searching for the smallest one, and once you find the smallest one, it's nothing bigger, you put it first, cross it over, go again for the second one, and so on. This is going to take some time. It would be better, of course, if you have TI-83 or 84 calculator, or if you have an Excel spreadsheet. Anyway, I ended up with something that has a range between 3 and 26. The range of the data of the sample is 23. If I want to make a histogram, I need to keep in mind few things. First, histogram has to cover all of the data. Second rule is going to be that there should be no gaps. Between the bars of the histogram. So now it's my choice to determine how many bars, the so-called classes, bins, I need to have. I am going to select 6. The rule is that you need to have at least 5. At least 5 bars, at least 5 classes. The choice of number of classes will depend on how many things you have in your sample. Since there are not too many things, this is only 30 items. 30 would be considered to be a large class. 29 would a large sample, excuse me. 29 would be small. That's just a very arbitrary break point, but we have to have something like that. So this would be relatively small, large class. Let's put it that way. I have 30 items, so I choose only 6 classes. Now I have to decide the width of a single class, and they all have to have the same width. There will be another rule that would say that you have to have a histogram that is unbiased. That will be somewhat in the eye of beholder. I will show you the reason later. So I am trying to cover a range of 23 with 6 classes. So I have to decide the width of a single class, and they all have to cover the range of 23. I'm dividing the range of sample with the number of classes, and my end result here is 3.83 with repeating 3 as digit. Now you could select something like 3.85, but in that case you have to do lots of calculations. So I am rounding that to the nearest integer, which is 4. Since I have 6 classes, each of the width 4, the total range of my classes is 24. Now you have to decide how you're going to cover that. Since the range of the data is between 3 and 26, you have to make your classes in a way that you are going to cover all of that. So that makes, in unbiased way, I would start with 2.5 and I ended up with 26.5. That would be a range of the histogram, which is 24. It is a good idea to have boundaries that would contain no item from the sample. 2.5 is nowhere in this sample, so 0.5 is a good idea to use, but that will depend on the data. The next step I'm going to determine are the boundaries. The boundaries will be determined in the following manner. The first boundary is obviously 2.5. The second boundary is going to be for the class 6.5. That's 4 more because it has to be of the width 4. The next boundary is going to be 10.5. The next boundary is going to be 14.5. Now we are at the middle of the range of the histogram. The next boundary 4 more, 18.5. The next boundary 22.5, and the last boundary 26.5, as listed here in this table. Now in the first column of the table I have class limits. This is what is actually going to be in the class. The items between 3 and 6, which means 3, 4, 5, and 6. Okay, this is going to be very easy to count, and that count we call a frequency. So if I go to the sorted data, I can see that I have 3, 4, 5, or 6 in the very beginning here. 3, 5, 5, 6. The frequency of this class is therefore 4. The next class, the boundaries between 6.5 and 10.5, will have items between 7 and 10, as in 7, 8, 9, and 10. And again, the count ought to be visible in your sort. 7, 8, 9, 9, 10, 10, 10, 10. That is a total of 8. The frequency of the second class is 8. And the following class limits are 11 to 14. There will be 6 items you could count. The next one from 15 to 18 will have 8 items. The next one from 19 to 22 will have 2. Let's count again. So the limits are 19 to 22. That would be 20 and 22. That's nothing else, only 2. And the last class with limits between 23 and 26. Again, the boundaries are 22.5 and 26.5. So therefore, the items that could be between these boundaries are 23, 24, 25, and 26. And we have 2 of them, only 23 and 26. So now we determine the frequency. Obviously, if the data is not sorted, you might also resort to something called a tally. That is probably not going to be needed if you have any kind of electronic help like a computer or calculator. We have another column here that is about the midpoint of the class. That is very easy to determine. This is going to be the very middle of the class. So for example, the first class you have a 6.5 as a right boundary. The left boundary is 2.5 is determined very early. If you make an average of these two, you will get a 4.5, which is the midpoint of the class. So you have to make the average of 2 boundaries. 2.5, and 6.5. Add them, divide by 2, it's 4.5. Add 4 more, and you get the midpoint of the next class. Or you can average these two numbers, 6.5 and 10.5, and so on. So these are the midpoints of the classes. This is going to be important later down the road because we are going to make the overlay curves that are connecting midpoint. The cumulative frequency is what is up to that class, including the class itself. So up to the first class we have 4 items in the sample. Up to the second class we have 4 and 8, which is 12. Up to the third class we have 4, 8, and 6, which is 18. So up to the third class we have 18. In the fourth class we have 8, so 18 plus 8, which you can add column-wise, it's 26. That is cumulative frequency up to the fourth class. Up to the fifth class, 28. Up to the sixth class, 30. The end must be exactly the total number of items in your sample. If it's not, that means you missed something. Relative frequency is calculated in terms of a percentage, usually. I wrote that here as a decimal number. That is calculated by dividing a frequency of a class with the total number of things you have in class, with the size of the class. We call that the size of the class. When you divide 4 and 30, the end result is approximately 13%, 13.3%, but 3 keeps on repeating. So the next class would have the relative frequency of 26.7, and how I got that? By dividing 8 with 30. As a matter of fact, I made a approximation here that I was just simply making a double of the first class, which has half of the elements. So you can simply calculate by dividing 8 with 30. The next class, divide 6 with 30, you will get 20%. The next class, 8 with 30, you can repeat again. So this is going to be 26.7%. To make a correction here, 2 divided with 30 is again 6.7%. And 2 divided by 30 is 6.7%. Okay? So those are approximations. You can say 7%. But those are the relative frequency. Sometimes we make graph based on relative frequency. I mean histogram, that would be rather than a frequency histogram, which is a regular histogram, we could also make a relative frequency histogram. We will not do that in this lecture, but that's a possibility. Okay? So this is the formula for relative frequency. Class frequency divided with the total frequency of the sample, which is also called sample size. So total frequency is very often referred to under the name of sample size. By the same token, you can also call class frequency class size. This number, when you divide, is telling you what percentage of the sample is in the class. So for example, in the third class we have 6 items. We calculated the relative frequency by dividing 6 with 30, and we ended up with 20%. That means the total of 20% of the whole sample, 1/5 of the whole sample, is in the third class. Here is the histogram. Histogram is determined by using a scale and graphing. So it's not just a regular drawing, it's precise drawing. So we have the x-axis, which is where the scale of the data should be. So we have something between 3 and 26, so you should apply that. And you should definitely use measuring. Proportions are important. The y-axis is a frequency axis, how many things we have. So we have seen from the table that we have anything between 2 and 8. So that should be your scale on the y-axis. Not necessarily the same scale as the the one on the x-axis, but something that is uniform for the y-axis. And then we use the boundaries. So the first boundary is the 2.5, the second boundary is 6.5, again up to a scale here. The third boundary is 10.5, the next boundary is 14.5, the next one is 18.5, the next one is 22.5, and the last one is the 26.5. The height of a bar should be, for the first one, 4. You might even want to write it on the top of the bar if it's not visible from the y-axis. The next one, 8. The next one, 6. The next one, 8. And the last two are 2 each. Again, those are the frequencies of the classes. And they are just simply taken from the table. This is a histogram, and which is also called frequency histogram, because we use the frequency for the height of the bar. We could have used relative frequency, and in that case we will have something called relative frequency histogram. The graph gives you the information about the distribution of the data. So you can see there might be something more popular that people are buying it at gift shop that is somewhere between $7 and $10, and there's another popular thing that might be somewhere between $15 and $18. And then there is a less, anything more expensive than $20 is not very often bought. Okay, that is the information we get from this histogram, which is a better information than you would say just looking at the numbers. This histogram is also called bimodal because it has 2 hills. So it's bimodal. It is also more pronounced, with a more pronounced tail to the right, and that is also called skewed to the right. Histogram could be unimodal. Unimodal, a histogram that they have 1 hill. It could also be skewed to the right, or it could be unimodal and skewed to the left. These are important observations because we can, by using this observation, this kind of information, we could determine the distribution of the data that might be theoretical for us. Okay? So I already mentioned a couple of rules that we have. You need to have at least 5 classes covering whole range of the sample. There should be no gaps between the classes, and every data entry therefore has to be in some class. There should be no overlaps. That means that the boundary had to be clear. If we have any item in the sample, there will be 6.5. We need to know whether this is going to be included in the second class or in the first class. It cannot be included in both, and it has to be included in one. This arrow symbolizes that I have a boundaries for the first class that starts with 2.5 and ends at 6.5, but not 6.5. 6.5 is not included in the first class. The same thing in the second class. If there is anything that is the data value of 6.5, it would be included in the second class. 10.5 would not be. 10.5 is included in the third class, and 14.5 will be included in the fourth class. So this is the meaning of the arrow here. You could go vice versa. Instead of left in and right out, you could choose left out and right in, but you have to be careful. So this is a typical choice. Okay? Every class should have the same width as in our histogram, that would be 4, and you should avoid bias if possible. Avoid bias if possible. And again, The possible bias that you create would be if you use this blanket of classes and move it a little bit on the right side or a little bit on the left side, and in that case you would have overcover on one side more than on the other side. That kind of bias should be avoided unless it is not possible. Okay, here is another example of a histogram when the bias is more pronounced, so it's more of a problem. So I have a professional football players based on their age from 16s, random sample of 40. First thing I did is to sort the data. Okay, the data has to be sorted before you start working on it because it's going to be much easier. The range of the histogram will have to cover the range of the data, which is between 21 and 37. The smallest in the sample is 21. The largest in the sample is 37. If I use 6 classes again, I'm going to have to divide the range, which is 16, with 3. Okay? This is going to be a little bit of a problem because I end up with the something that is approximately, oh, excuse me, the range of the number of classes is 6. Right, so it's going to be somewhat of a problem because I end up with something that is again a decimal number. Two point something. So I'm rounding to 2 decimals, 2.67. And since I'm not going to use the decimals, I'm going to round it up to 3. So I'm going to have a class width that would be 3. 6 classes and 3 each would mean that I will have 18 for the range of my histogram. Now this is a bit of a problem because 18 is 2 more than 16. The range of the data from 21 to 37 is 16. So which means that if I try to avoid the bias at both ends, I will start with 20. So I have to cover the range between 21 and 37. And I'm going to use a blanket of 18, which means this is 2 extra. So I would be starting at 20 and ending up at 38. That's one possibility. If you do that, there will be plenty of things on the boundaries. We will end up with the boundaries being 23, so 20 to 23. 3 is the width of a single class, then to 26, then to 29, then to 32, then to 35. You will see there's plenty of things that are the ages in the sample that are 29. 1, 2, 3, 4, 5. So you have to be very careful about decision what class that they belong to. If we're talking about the left in and right out, we will have to put it in the 4th class, right? So that's one possibility. So we have 20 to 23, 23 to 26, 26 to 29, 29 to 32, 32 to 35, and 35 to 38. So the histogram turns out to be this way. This is now unimodal skewed to the right histogram. Okay, and that could be avoided to have lots of things on a boundary by choosing different boundaries. So instead of starting with the 20 and ending with 38, you could start with 20.5 and ending at 38.5. That would create somewhat of a bias, So the bias is to avoid here having too many items in the sample on the boundaries. This way you will have nothing on the boundaries because the boundaries are fractional, decimal. So you have a 23.5, 26.5, 29.5, 32.5, 35.5, 38.5. That's an option. Again, it's a little bit of a bias. You can notice I moved that, cover that blanket a little bit further. So I was using the boundaries to avoid having data on the boundaries. And again, if you do that, you can check this. It is a lecture posted on the Blackboard. You can check the table the way I was counting and finding out the class limits, frequency, cumulative frequency, relative frequency, and of course midpoint. I got this histogram. And if you compare the two, they're somewhat different, but they're both still unimodal and skewed to the right. Okay, so didn't change the shape of the histogram, it changes slightly what is in the classes. Okay, I have a third sample, in which case I have the data that is, after sorting the data, I have something between 0 and 51. So I'm going to leave that to you to sort, which means 51 is the range of the sample. If I use 6 classes, again, you do not have to use all the 6 classes, you can use something else. But I use 6 classes to comparison with the previous histogram. And 51 divided with 6 is 8.5. If you round this and you use the width of a single class to be 9, then you're going to have to cover the data that is between 0 and 51 with a cover that is 9 times single class width, 6 of them, 54. 9 times 6. So you could choose to make a 1 to 54. I should say 0 to 54, right? 0 to 54. Or you could choose totally unbiased approach and use negative 1.5 to positive 52.5. Now, if that negative confuses you, avoid that. Your choice. Because there will be no negative luggage in this sample. This is a sample of 40 passengers carry-on luggage in pounds. Nobody's going to carry anything negative into the cabin. But then again, if you choose 0 to 54, then you would have a big gap here of data. In the last bar, it will be 3. The size of the width of a single class is 6. Half of that will be empty because there will be no data in the sample that would fit in that class. So that particular class will be smaller because of your choice. That makes somewhat of a bias. So either way is fine. You probably would like to do that, I'm assuming, because it's going to be much easier to work with no negative numbers. But here's a table that I use for the boundaries between negative 1.5 and 52.5. Of course, the class limit is going to be between 0 and 7. There will be no negative luggage. And you can check this data, and that's what I get as a histogram. Now, this is a unimodal skew to the left because the pronounced tail is on the left. If you use this division of the sample, then it's going to be of the same shape. There will be no change in the shape. So you might want to try that yourself. Again, the overlay of the histogram, it's not done by drawing something like that. That's only, I was using that myself just to give you some idea. when I'm talking about the shape of the histogram, it's actually done by something we call a frequency polygon. Now the frequency polygon has two words, frequency and polygon. Frequency, you already know what that means. It will be a frequency of every single class. The polygon is a Greek word that would mean something that is a set of line segments connected at the end point, something like this. The polygon could be also closed, so you probably heard of the word rectangle and triangle and so on. But it could also be open like this. So that would be the idea of the polygon. Okay, so how is this particular polygon here determined? It's determined by using coordinates of these particular points. Once you find those coordinates, you're just gonna connect them with the line segment. Two points next to each other in terms of x-axis are connected with the line segment. The first coordinate is the midpoint. So in this carry-on luggage, the midpoint is 3. Okay, so you average these two numbers to get 3. If you get a different sample, it's going to be something else. You average these two to get 12. You average these two to get 21. Again, making an average is easy. You just add two numbers, divide by 2, you get 21. You average these two, you get 30. Or you can just simply add 9 because that's the width of a single class, so that will give you the next midpoint, and add 9, that will give you the next midpoint. So it's 3, 12, 21, 30, 39, and 48, as you can see here. 3 is the first coordinate, 12 is the second, 21 the third, 30, 39, 48. How do you get the y of the coordinates? Simply by using frequency. So those would be 2, 2, 9, 16, 8, and 3. So here is the frequency. You of course have to check that out. Make sure this is indeed the number of items in the first class, second class, third class, 16 in the fourth class, 8 in the fifth class, and 3 in the last class. Once you connect that, this is called a frequency polygon. Okay, this will give you an outline of the histogram, and it gives you again the idea that you have unimodal skewed to the left histogram. Okay, we have also something called an ogive. Ogive as in O-G-I-V-E, not a jive. Right? So people tend to remember this as a jive. It isn't a jive, this is a French word. And in this particular case, it actually means cumulative frequency polygon. Now this is done differently. Again, you need to find the coordinates of these points. The first point, the second point, the third point, and so on. And you have to connect them by using line segments. So the coordinates of the points are right boundaries, 7.5, 16.5, 25.5, 34.5, 43.5, and 52.5. You take a look at the table, that's precisely what the right boundaries are. Okay, the second coordinate of the point, the y of the points, are cumulative frequencies. 4, 37, 29, 13, 4, and 2. 40, 37, 29, 13, 4, 2. And once you find those points, again, the first coordinate is the right boundary. The second coordinate is cumulative frequency. Then once you find all of those points, you collect them with the line segments. It's also often done that is connected to the 0, 0 at 0 or the left class will be, in my case, negative 1.5. I'm not going to do that. Now what is this telling you? It tells you how the data accumulates. So up to the boundary 16.5, you already have 4 items in the sample. Up to the boundary 25.5, you have 13 items in the sample up to 34.5, 29 items in the sample up to 42.5, 37, and then in the last class you have only 3 more. This tells you how the data accumulates. In the beginning of the sample it goes slower, and then it goes faster. Accumulation happens faster and then slower. This is a very typical curve called S curve. You see the shape. Or a sigmoid if we use Greek letter S, which is a sigma, sigmoid curve. It's also called logistic curve. This is very typical of any unimodal histograms. They will have a curve like that. The growth could be a little bit slower at the end and in the beginning, and the difference between those two will be determining whether it's skewed to the right or skewed to the left. Again, this curve is called ogive. Okay, and it usually starts at the right boundary of the first class, but it could be the left boundary of the first class, in which case you should start with 0 items in it, because there's nothing before the first boundary. There are no items in the sample. You will see that in your homework that the author of the homework likes to put the left boundary first with 0, and then it goes right boundary, cumulative frequency, right boundary, cumulative frequency, right boundary, cumulative frequency, so on. Okay, so this is the story. You should check the homework that is online and work on those histograms there. And you could pose your questions to me. Thank you for watching. I hope you get something out of this lecture. The lecture itself is posted on Blackboard in a written format.